we're hoping to do at Coldwater Cave is interpret ancient climates from the rocks that are in the cave. Stalagmites and stalactites and other cave growths form from the precipitation of the mineral calcite, which is the same mineral that's in limestone. As you probably know, it comes out of water. So in other words, this water contains a signal of the climate, and that signal is acquired through the water in rain and the carbon dioxide from plants. And both of those signals give clues to what climate existed on the surface at the time the mineral was deposited. In the late 1800s, the first state geologist in Iowa named Sam Calvin characterized the geology in Winneshiek County, and he described this spring called Cold Spring, and he describes it as this kind of thin cavern system that discharges this amount. But in the late 1970s, a couple amateur geologists were running around near the spring and saw it, got curious, and were wading up to the discharge in about 3 feet of water and noticed that you could swim underneath it. And so they got a wild hair and decided to go for a little swim, and swam through a series of sumps at pretty great risk to their lives, and came out in this big cavern known as Coldwater Cave now. Let the games begin. Okay, rip it up. It's really intimidating at first when you're in the cave to begin with, because you go down this small hole and you're climbing down this ladder for about 100 feet onto this wooden platform, and it's completely dark. So it's really pretty eerie to begin with. And then you get down there and there's just water flowing all over the place. It's just like a stream. Coldwater Cave is especially significant scientifically because it has no natural entrance. It simply is this cavern in the subsurface that's never been exposed to the atmosphere. And so as a result, the air is always at 100% humidity. The carbon dioxide levels in the cave are always uniform. So it's a really great opportunity for us to get a lot of information from the rocks and from the water in that area.
Here's the hole taking up a lot of the picture there. Move it down. And there are the bands. Each one of those we think are a year. So we can see how many years are being eaten up by this hole here. That's the material that's being used for the isotopes. And that's what Aaron's looking at, is the isotopes, how they change from the top of the elevation, of the very top of the surface, how it changes from there all the way down to where he's at in the cave, and where these are being formed. Now sometimes we can see that these thicknesses change. Oops. Right here it seems we had a sudden shift in pattern where we had the present is towards this end over here, and the past is back here. So it was nice and wet, wet year, wet year, wet year, wet year, and then suddenly these become very thin bands, which says that maybe we had a climate shift that occurred here, and it didn't happen gradually, it suddenly switched over.
It's a really, really unique experience to be able to be in a place like that that's been so unaffected by any humans at all. And you know when you're down in there that it's not a normal place, that you don't really belong there. But it's pretty special.